Too often, technicians see one odd scan data PID and replace the sensor or part. But trusting one number without context can lead to expensive mistakes. This lesson shows how to avoid that trap and what steps actually produce proof. A scan data PID is only as reliable as the context in which it was read. The ECU sees input voltages and calculates values based on its logic. But that PID alone doesn't always reflect real-world conditions. True understanding comes from knowing what should be present under the exact system behavior and comparing it to both expectations and related data. To trust a PID, compare its value to what you expect under current operating conditions, such as temperature, engine load, or sensor correlation. For example, if intake air temperature reads below freezing on a warm day, or throttle position doesn't match pedal input, something is wrong. Compare this suspicious PID to related signals or direct measurements to avoid jumping to conclusions. When you find an abnormal PID, don't guess. Look up the related signal, like comparing coolant temp and intake air temp, or verifying sensor voltage at the ECU pin. Sometimes it's about recreating the condition. Does the PID shift as expected when changing system state? Only a targeted test or direct comparison can confirm whether the PID reflects a real fault or misleading data. Here's the trap. You spot a scanned PID out of range and swap the sensor, hoping for an easy fix. But without confirming with context, correlation, or a direct test, you risk parts cannon, wasting time and money with no result. Save replacements for when the evidence and testing prove the fault. Never trust a single scan data value alone. Always check the operating condition, compare to related PIDs and real signals, and finish with a proof test. Accurate diagnostics save money and prevent misdiagnosis every time. To master diagnostics, always think beyond one clue. Compare, test, and prove the fault for every repair. STEP delivers the logic you need.